Hello guys, welcome back to the channel. So today in this tutorial we are going to see the difference between an array list and linked list. Now let's say somebody gives a problem to you. There can be multiple data structures which you can use to solve that particular problem. But see, we have to become great programmers. So we have to come up with something efficient and optimized, right? We have to come up with a data structure which is efficient and optimized for that particular problem. So in that scenario, we cannot use any data structure, right? We have to use some efficient and optimized data structure for that problem. So that is why understanding the difference between the data structures is extremely important. Now, what is array list? It is a data structure. What is linked list? It is also a data structure. Both are the implementation of list interface. Now, there can be multiple operations that can be done on array list as well as linked list. So we are going to deep dive. We are going to see the operations, what can be done, what cannot be done, which is more efficient, which is not so efficient, right? Everything in detail. So without any further delay, let us start this tutorial. Okay, so the first key point, the first key difference between an array list and linked list is array list uses dynamic array internally. Now we will understand, we will read about dynamic array, don't worry. While on the other hand, this linked list, it uses doubly linked list internally. Okay, that is the first difference. Now let us try to understand the dynamic array. But before that, let me walk you through the initialization process. How do we initialize an array list? How do we initialize a linked list, right? That is important to understand. But before that, we have seen in Java series that how do we initialize an array. You remember this, right? We always give this size while initializing an array. So this is the correct statement, but this is not correct. This is absolutely wrong, right? Because this is not the valid syntax. Why? Because we have not given the size here, right? This is empty. We know that, nothing new. Okay. Now come to array list. Array list says that you can initialize me with or without initial capacity. So this is how we initialize the array list without the initial capacity. In that case, the default capacity is 10, right? In that case, the default capacity is 10. In which case, when you do not give the capacity explicitly. But if you want to initialize with some capacity, with some initial capacity, right? So you have to pass that initial capacity in the constructor, like the way I have passed here, 20. So basically, I said that, okay, array list, I am initializing you with an initial capacity of 20. So you can store 20 integers. But here I have not mentioned any number, any initial capacity, right? Okay, cool enough. Understood so far. Now this is the linked list thing. In case of linked list, guys, we do not give the initial capacity. I mean, there's no way we cannot initialize it with the initial capacity. So that is how we initialize the linked list. So we create the object of linked list. We can use the reference of the interface list. We cannot instantiate list because it is an interface, while linked list and array list, these are the classes. So we can definitely use this new keyword to create the object of array list and linked list. Now we have understood this. Now we are more interested in dynamic array. Okay, let's go to that. So guys, this is very fancy thing, very amazing thing. So let's say I write this statement where I am not giving the initial capacity, this one. Okay, so what will happen? It will initialize it with the initial capacity of 10, which is default. Now let's say I insert 10 numbers one by one. So first I insert 5, then 4, then 3, then 2, and so on and so forth. And then in last I insert 6. Now what will happen after this? Because the capacity is full now. All the 10 elements have been inserted. What will happen after that? So remember, this is a dynamic array. So what happens in case of a dynamic array? So now let's say I try to insert 11 in this array list. Remember, this is an array list, not linked list. So now I have to add this 11. How will I do that? See guys, now because this capacity is full, all the 10 elements have been inserted. Now when we will try to add this 11, a new array will be created. What will happen? A new array will be created. A new array, this is the new array that will be created, and it will have 1.5 times the size of the original array, this one. So if it had 10 elements initially, if it had 10 capacity, it will have 15, right? 1.5 times of the original one. So this is 10, which comes from here, Now plus 5 because we have to do 1.5 times. So 10 plus 5, 15 blocks. So now these are the 15 blocks. So all these elements you are seeing in the original array, all of them will be copied in the new array. Listen again and listen carefully. All these elements that were there in the previous array with initial capacity 10 will be copied to this new array, and in this case the capacity would be 15, the 1.5 times of the original array. That is what we call dynamic array. That is dynamic array because when you are inserting elements, it is increasing its capacity, it is increasing its size, right? Earlier it was 10, now it is 15. So now we can insert 4 more elements, right? Because these are empty blocks. So let's insert 12, 13, and then 14 and 15. Now let's say I have to add 16. What will happen now? Now the capacity is 15. What is the capacity, guys? This is 15. Now it will again increase the size to 1.5 times. Now it will become 1.5 into 15, or it can be written as 15 plus half of 15, which is around 7.5, exactly 7.5. So it would be around 22 because we cannot have 22.5, right? So let's say 22. So now an array of 22 elements will be created, guys, and all these 15 elements will be copied to this array one by one, like 5, 4, 3, 2, 7, 8, 9, and so on. And in last we will insert this new number that we are trying to add, which is 16. So 16 will be added here, and because this is the 16th element, right? 15 was there before, now this is the 16th, so there will be 6 more blocks like this, right? So this is how dynamic array works. When you try to add a new element and the capacity is full, all the elements will be copied to the new array, and then this new element will be added, will be inserted. This is a very amazing thing, right? Because you are not initializing the array list with the initial capacity, correct? And if you are not sure about the data, about the size, then always go for array list because it increases the size dynamically. It uses dynamic array internally, right? So now the size is 20. Now let's say you add elements from 16 till 21, 22. It will again create a new array. If you will try to insert a new element, it will again create a new array of size. Right now the size is 22 plus half of 22, which is 11, 33. So if you will calculate 1.5 times of 22, it will be 33, right? So it will copy all the elements from this array to a new array which will have size of 33, and it will add these numbers 5, 4, 3, 2 one by one in the new array. Here 5, 4, 3, 2, 7, 8, 9. So this is how insertion works in an array list. This is what we call dynamic array. Got it? I hope this is clear to you now. Now let's come to the linked list thing. It uses doubly linked list internally. What is doubly linked list? It is easy. It is very easy. Okay, guys, doubly linked list is a data structure which can basically store two things, basically three things. So one is data. Let's say I add an element 5. This is my data. What is this? This is my data. Okay, now it can store the address. It can store the address of the element which is on the right side of this node. Okay, and we call this as, let's say, node. What do we call it? A node. So this side of this node, the right side of this node of this data will be pointing to the right side to this particular data. Okay, now let's say the value is 10, and let's say this is node 2, and let's say this is node 1. Now let's say the memory address of this particular block is 100 and the memory address of this block is 101. So it will store 101 here. Okay, and let's say before 5 we have another data, and let's say the value is 3, and let's say its address is 99. So it will also point to the right data, which is 100. So it will store 100 here, and let's say there is nothing on the left side of 3, so it will store null. What will it store? Null. And it will store 99, and here it will store 100, and let's say there is nothing on the right side of this particular node, so null. So see, this is the doubly linked list. How? You can go from this to 101, right? Because there is a pointer which is pointing to 101 from 100, right? On the other hand, you can go from 101 to 100 because you are storing 100 here. So you can go here also and you can go on the right side also. From 99, you can go to 100 and from 100 you can go to 99 as well. Because 100 has the information of 99 and 99 has the information of 100. So doubly linked list is a data structure where you can go to the right as well as left from a single node. So from this node, that is node 1, you can go to the right and you can go to the left as well. Correct? So this is doubly linked list. But for the students who are in college, who are doing their bachelor's or master's or whatever, we are going to cover doubly linked list in detail. We will be implementing it from scratch. So now we have studied dynamic array. What is it? We have seen doubly linked list. Now let's come to this part, contiguous array and non-contiguous storage. So in case of array, guys, what happens? Let me tell you. We have studied it in Java series as well, but let's touch upon it again. So let's say I have a memory block. So let's say I have these elements 1, 5, 2, 3, 8, 7, and I have to add this in an array list. Which data structure? Array list. So if I place 1 here, so it is mandatory for me to place 5 here. I mean, I am not going to do that. User cannot do that. It happens internally, but I am trying to tell you, you cannot put 5 here. You cannot put 2 here. You cannot put 3 here. You cannot put 8 here, right? You cannot do that. I'm again telling you, we do not do it. It happens internally, but I am trying to tell you, right? I am trying to make you understand. So if you place 1 here, then 5 will be placed here, 2 will be placed here, 3 will be placed here, 8 will come here, 7 will come here. In case of array and an array list, because array list internally uses array only, dynamic array. So all the elements have to be contiguous. All the elements have to be placed in continuous memory blocks. So 1 will come before 5, 5 before 2, 2 before 3, 8 before 7, and so on, right? So this is what we call as contiguous memory. What, students? Contiguous memory. So in case of array list, the elements are stored in contiguous fashion. While on the other hand, in case of linked list, the elements are stored randomly. Now what do I mean by randomly? Let's see that. So now let's say I have to add 6, 10, 12 and 15, and now I have to add these elements in linked list. Okay, so how will I add it? Or basically it happens internally, right? I have told you this multiple times, so it happens internally. So let's say 6 goes here. Now 10 can go anywhere. Let's say 10 go here. This 12, the next element, can go here. This 15 can go here. Now 6 will be connected to this 12. Sorry, 10. Not 12 but 10. 6 will be connected to 10 like this through pointers. It happens through pointers, right? 10 will connect to 12. Now this 10 will connect to this 12. And this 12 will connect to 15, right? This 12 will connect to 15. And it all happens, everything is happening through pointers. What, guys? Pointers. So 6 will have the pointer, 6 will have the memory address of 10, 10 will have the memory address of 12, 12 will have the memory address of 15. But in case of contiguous memory allocation, we do not need it because we know that the next element is just 1 block away from me, is adjacent to me. But in case of linked list, we do not know that. We don't know that, right? We don't know that after 6, where is 10? So somehow we will have to store the information of 10, right? So we store the address of 10 inside 6 here, let's say here, like we studied few minutes back, right? Now, if I have to go to 12 from 10, then how will I know it? Because it is not contiguous. I cannot say that in case of linked list, the next element would be adjacent to 10. No, it is not mandatory. That is not how linked list works. So I'll have to keep the information of 12. So there will be a pointer from 10 to 12, right? This one, see this one. And similarly, we will be having a pointer from 12 to 15. Got it? So that is why we say that an array list, the elements of an array list are stored in contiguous memories, right? But in case of linked list, nothing like that. You can store, or the element is stored anywhere. and everywhere. Okay, but they are connected with the pointers. They are connected with the pointers. They are connected through pointers. Okay, got it. Next point. New array is created on full capacity. We have seen it, right? Because when we tried to add 11, when we tried to add 16, all the elements from the previous array will be copied to the new array with an increased capacity, right? We have seen it. Go back and see it again. Okay, you will understand if you have not. Now let's talk about it. Memory is allocated independently. Now what does it mean? So if you remember, we do not initialize the linked list with any initial capacity, right? You remember, guys? So what does this point mean? Memory is allocated independently. Let's see it. Let's see it. So let's say you have taken a linked list and now you have to add one in the linked list. Initially it is empty. So what happens? A node will be created which will keep this one. And right now, because this is empty, because the linked list was empty and this is the first node that we are adding, so the right side would be null, the left side will also be null. Okay, now let's say you add 2. So a new memory block will be allocated. At runtime. So what will happen? A new block will be created. It will have the data 2. Initially, it will have also these values as null. But now, because you have added 2 after one, so this left pointer, this one, okay, it will have the memory address of 1. And we know that each and every memory block has its own address, right? Similar to our house, whichever house we are in, it has its own address, right? So similarly, each and every memory block has its own address. So let's say the address of this block is 100 and the address of this block is 101. So here it will store the information of 100th node. So here 100 will come. Okay, so once you place 100 here, again it happens internally. So a pointer will point to 100. The left side of this particular node will point to 100. Now because it is based on doubly linked list, the linked list in Java is based on doubly linked list implementation. So because this node comes after this node, so on the right side here we will store the address of the right pointer, the right node basically, which is 101. So here 101 will come. And now once you place it here, it will start pointing to the right side. The second node, which is 2. Getting it? Cool. Now let's say you insert another node with value 4. Initially, left and right pointers are null. But because you inserted it after 2, so ideally there should be a pointer from 2 to 4. And we know that 4 is on the right side of 2. So here we will place, and let's say the memory address of this 4 is 103. Random I'm taking, right? So you will place 103 here. And as soon as 103 is written over here, it will start pointing to 4. And now because on the left side of 4, we have 2. So memory address of 2, which is 101, will be written here. And as soon as you write it, as soon as you fix these pointers, this will start pointing to 2. So guys, that is how doubly linked list works. So whenever we have to add a new element, a new node is created, all the pointers are fixed properly. So if you insert at the end, the left pointer will be pointing to the second last, right? If you try to insert at the front, at the start of the linked list, the right pointer will start pointing to the second from the starting, right? So that is how the insertion in doubly linked list or in linked list works in Java. So there is no mechanism, there is no concept like initial capacity. Okay. Now in ArrayList we have faster iteration, while in case of linked list we have slower iteration. So understand guys, this is theoretical and you can easily get it now. See, we have seen that an array, the elements of an array list are stored in contiguous fashion, right? While in case of linked list we do not have contiguous memory allocation. So because of the pointers overhead, because you do not know that, because see, in case of ArrayList, you are damn sure that okay, the next element is just adjacent to me, right? So you can directly jump there, you can directly go there, you can directly go on that node. But in case of linked list, let's say, because it is connected through pointers, so iteration takes time. But in case of ArrayList, because all the elements are neighbors, all the elements are in adjacent memory blocks, so it is easy, it is faster to iterate. Okay, lower memory overhead, higher memory overhead. So in case of linked list, we say that higher memory overhead. Now many of you must not be getting this term, right? But it is easy, let me explain it to you. When we say lower memory overhead, I ask you a question. Do we store pointer information? Do we store pointers information anywhere in ArrayList? No, we do not do. We don't store. But in case of linked list, we have to store the information of the left as well as the right pointers. See here, we have to store the information of the left as well as right pointers. Here we are storing the information of left pointer. Here we are storing the information of the right pointer. Here we are storing the information of the left pointer, right? So this is a memory overhead, because we are not storing just the data. Apart that, we are storing the information about the previous as well as the next node. So we are storing multiple things. We have to take care of multiple things, not just the data. But in case of ArrayList, we do care only about the data, right? So that is why ArrayList we say lower memory overhead, but in case of linked list we say higher memory overhead. I hope it is clear to you guys, right? Now let's talk about operations. What do you mean by operations? Okay, so let me try to explain it like this. So you remember array, right? You remember array. We can add an element in array, right? We can do that. We can fetch an element from an array using index, right? So these are the operations. These are known as operations. So in case of list, array list as well as linked list, we can do insertion at the beginning, middle, also in the last. So insertion can be done at the beginning, at the middle, at the end of an array list as well as linked list. Cool. Search, of course, we can search in both the data structures. When it comes to deletion, we can delete from the beginning, from the middle, from the end. If you remember, can we delete an element from an array? No, we cannot do that. We remember that. We cannot do that. But in array list, in linked list, or in list we can say, because list is an interface and array list and linked list implements the interface. So we can say that in list we can delete the elements. Now we are going to see the time complexities involved in these operations for both array list and linked list. First, let's talk about insertion in an array list. So let's say you have this array list. Okay, you have this array list. Now this array list has, let's say, some elements 5, 3, 2, 1, 8. Okay. Now I have to insert an element at the beginning. Let's say I have to add 10. Okay. How will it happen? And I have to insert it at the beginning, means 0th index. So what will happen now? You have to watch this carefully. You have to understand this carefully. And it has the capacity of 10 initially, right? So it has 10 elements. But we have stored only 5 till now. Now we have to add 10. So, and where? At the beginning, at the 0th index. So see what happens. All these elements 5, 3, 2, 1 and 8 will be reshuffled. How? 8 will go here, 1 will go here, 2 will go here, 3 in place of 2 and 5 in place of 3. So reshuffling will happen. And then after the reshuffling, how will the array look like? This 5 will be here, 3, 2, 1 and 8. And now we can place 10 at the 0th index. So what is the time complexity of inserting an element at the beginning of array list? It is O of n, where n is the number of elements present in the array list. Why? Because we are reshuffling all the elements one by one. We first reshuffled 8, then 1, then 2, then 3, then 5. So the time complexity is O of n in case of an array list, if you have to insert the element at the beginning. Okay, let's talk about the middle thing. Anyways, we can figure out it. It is again O(n). How and why? Now let's say I have to add 15. Let's say at third index. Okay, so what will happen now? This is 0th index, first index, second index, third index. Now this 8 will be reshuffled and it will go here. This one will go in place of 8, and now this time the array will be like this: 10, then 5, 3, and now 15 will come here, right? Because we have to insert it at third index. Okay, so this is the third index, so 15 will come here, 2, 1, and 8. So this is how it happens, the insertion, right? So let's say if I have 1 lakh elements and I have to insert at the beginning, then I'll have to reshuffle all the 1 lakh elements. If I have to insert an element at fourth index and I have 5 lakhs elements, then I'll have to reshuffle 4 lakhs 99,000 something number of elements to the right side, and then I'll add the new element, right? So the time complexity will be on. How much? On, for both insertion at the beginning as well as in the middle. Now let's talk about the time complexity if we have to insert an element in the array list at the end. So if we have 10, 5, 15, and let's say I have to add 16, so of course I can simply add in the last. So this is basically O1. Now here comes the interesting part. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. Now initially the capacity of array list is 10. So we have 10 elements here. Now I have to add 11th number at the end here, right? But now all the elements will be copied to the new array, correct? If you remember it correctly, we studied it a couple of minutes back. All the elements will be copied in this new array, and then 15 will be placed here, and there will be 4 more blocks because these were 10 blocks. Now it will be 1.5 times of 10, which is 15. So now one by one will come here, then 2 will be copied, then 3 will be copied, then 4, then 5, then 6, then 7. So in this case, in this particular scenario, the time complexity would be of n, because each and every element is being copied to the new array, correct? But now let's say I have inserted 11, I have added 11. Now I have to add 12 at the end only. So because now total number of elements in this list are 11, and the size of the array list at this point is 15, and I have to insert this 12th element. So I can simply add this 12 because the size of the array list is bigger. So in this case, the time complexity would be O1. So now you must be wondering, then in the previous case when we were adding 11, the time complexity was On. Now we are adding 12, so time complexity is O1. How is it happening? Because right now the number of memory blocks are enough to store a new number, right? If I have to add 13, I can store 13 here, right? So guys, listen carefully, understand this. It is seen that the overall time complexity, overall insertion time complexity at the end in case of an array list is O1 only, because this operation happens very rarely. This resizing, what do we call it? Resizing. Because see, earlier the size was 10, now the size is 15, so this is resizing basically. So it is seen that resizing happens very rarely. So the amortized time complexity, what is it? Amortized. Basically understand it like this: overall time complexity, overall, including each and every operation in the insertion, right? That time complexity is basically O1 only. So now you understand this, right? Now let's talk about search. See, if you have to search by index in an array list, it is O1, guys. It is O1 because array list is backed by an array, right? But if you have to search by value, that you have to find 7, then of course you will have to iterate this entire array list, right? But if you want to access the index, let's say you want to access this fourth index, then of course you can write it in O1. But if you have to check whether 8 is present or not, 9 is present or not, then you will have to iterate this entire array list, and then in that scenario the time complexity will be On. How much? On. So this is search by value if you are looking for a value. Otherwise, time complexity can be O1 if you are searching by index. Understood? Cool. And this is in case of array list. We haven't seen linked list yet. Now guys, let's talk about deletion. So okay, if you have to delete from the end of an array list, so you can simply delete this 12, let's say. So this is O1. If you have to delete from the middle, let's say you want to delete this 6, you can delete it, no worries, but you cannot delete it in array, remember, but you can do that in array list. Let's say you have to delete this 6, you can for sure, but all these elements to the right, all the elements on the right side will be reshuffled, and 7 will come in place of 6, 8 will come place, it will come in place of 7, 9 will come in place of 8, 10 will come in place of 9. So again the time complexity would be on. In case of deletion, if you want to delete a data which is present in the middle, then the time complexity in array list would be on. Beginning, of course, if you delete this 1, 2 will come in place of 1, 3 will come here, 4 will come here, 5 will come in place of 4. So the time complexity would be on because of the reshuffling. So let's talk about linked list now. Now let's say you have to delete this particular node which is present in the beginning, right? So in the case of linked list, doubly linked list, it maintains 2 pointers, one at the head and one at the end. So you can simply delete this head node and you can set this head pointing to 7. So your new head would be at 7. So the time complexity, if you have to delete at the beginning of linked list, it would be constant O1. Similarly, if you have to delete at the end, again it would be O1 only. Why? Because you can simply delete this end pointer, or you can simply set this end pointer here on 7th. So you will get rid of this, right? So this is also O1. Now let's talk about the middle. There is no way, similar to array list, if you have to delete this 7th, you will have to iterate this linked list from the beginning. You will have to iterate this. So the time complexity would be O of n in case of linked list also, right? But see, when you deleted an element at the beginning, in case of linked list, the time complexity is O1. But in case of an array list, it was On. Remember, it was On. So look at the difference. If there is a use case, understand it carefully. If there is a use case where you have to delete or insert elements frequently at the beginning, then you must go for linked list, not array list. Now we are done with deletion. Now let's talk about insertion, guys. Of course, if you have to search, it is same as the array list. Okay, no changes. So let's talk about insertions. So this is head, this is end, this is the last pointer, this is the starting pointer. Okay, so now let's say you have to insert at the beginning. So what can you do? You can simply create a new node, let's say whatever value, let's say x. Okay, you can set the right of this pointer to 5 and left null. So this is, let's say, value 10, right? And you can make this head pointing to here. So this will be removed, and this new pointer, the head pointer, will start pointing to this new node which is 10. So the time complexity of inserting an element at the starting, at the beginning of a linked list is O1, because there is no reshuffling happening, right? Nothing is happening. You are just pointing this head to the next, to the new pointer. That's it, nothing else. If you have to append or if you have to add element at the end, then of course you will create a new pointer, let's say with value 12. This will start pointing to this node because 8 will appear before 12, right? And this end will now start pointing to this 12. So this connection, this pointer will start pointing to 12, the end pointer basically, right? So now this new node 12 will become our end. So this is again O1 at the beginning as well as at the end. But let's say if you have to insert an element at the middle, then obviously you will have to go till that element. You will have to iterate basically the list, and in that scenario the time complexity would be O of n only. In the worst case, we are talking about big O, the worst case. So guys, I hope this tutorial has been helpful for you and you like this tutorial. And if you like the video, please do share and subscribe to the channel, like the video, do share it with your friends. Now we will meet in our next video. Till then, bye, take care, all the best.